Okay, so this is lesson 7.5, modeling data using logarithmic functions. So example number 1, caffeine is found in coffee, tea, and soft drinks. Many people find that caffeine makes it difficult for them to sleep. The following data was collected in a study to determine how quickly the human body metabolizes caffeine. Each person started with 200 milligrams of caffeine in his or her bloodstream, and the caffeine level was measured at various times. So what they're giving us is a chart. So what we're going to have to do first is enter all these values into our chart. This is going to be our X value, and this is going to be our Y, X, and then Y. So the caffeine level is our X coordinate, which on your calculator, they know it as L1. And your time after ingesting the caffeine is going to be labeled as Y, which is your L2. So we're going to have to enter all those caffeine levels into L1 and all the times after ingesting into L2. So they want the equation of the logarithmic regression. So whenever you see the word regression, they want you to go to your graphing calculator. They want you to press stat, then press number 1, which is enter. And what you're going to do is enter all those values of the caffeine level into your L1. As you can see, I already did that. And then all the times after ingesting into your L2. So you'd put the caffeine levels, that first column, into L1. Then you're going to do the third column also in L1. You just continue on with 33. And then you're going to go to L2 and put the time from 1 all the way to 12.5, and then go to the fourth column and put the time 14 all the way to 19. So that will continue into L2. So you only ever fill out L1, L2. Once you have those filled in, so what you're going to do is pause the video and enter those in, because I'm going to continue and show you what to do after you've entered in the value. So pause the video. Okay, so hopefully you've put those into your calculator, and now what you're going to do is you're going to press stat. You're going to go to the right where it says calc, and for you guys, you're going to do logarithmic regression. And logarithmic regression for you guys is pressing number 9. So you guys are going to press number 9 for LN regression. Okay, and it should look like this. So when you press number 9, it says LNREG. That's the only number you press when it says logarithmic regression. Then you're going to keep pressing enter until it calculates this for you. So you should have the exact same numbers as me. If you have different numbers than me, that means you probably missed a value in your chart, or you put in a number in your chart incorrectly. So you're going to have to go back to your charts and check all your points and make sure that they're entered correctly, because even 1 point off will adjust this equation or make it wrong. Once you have this equation, we're going to write it down into our notes. So the logarithmic equation to the nearest hundredth would be y equals, it's going to be a first, which is 44.39, minus your b value. So it's 8.36, because normally we have a plus sign here, but since we're putting in a negative number, it's going to become minus 8.36, and then ln, which is ln of x. So that's the equation that you should have as your answer. Once you have your equation done, we're going to go back to our calculator. We're going to go to y equals. You're going to press vars number 5, where it says statistics for you guys. And then you're going to go to the right till it says equation EQ, and then press number 1. What that will do is copy and paste your equation into Y1 so that you have accuracy and your answer is not going to be wrong. Once you have that entered in, you're going to go to your window. You're going to enter the smallest caffeine level that we had, which was, I see 18. So you just want to double check and see if there's anything lower than an 18. So I'll put 18 for our X minimum for the caffeine level. And our highest value, we're going to write it as 168. So that's our L1s. Our L2, our lowest value from what I'm seeing is 1. For our Y minimum, and for our Y maximum, our highest time after ingesting, I see, let's see. I see a 20. So I'm just checking if there's anything higher than a 20. So no, so I'm going to put in 20 here. And then you're going to graph it, and you should see that X, in this case, this is that, what it's looking like is, this is a logarithmic equation. So once you graphed it, the question, you're going to go back to the question and read it. It says, determine the time it takes for an average person to metabolize 50% of the caffeine in his or her bloodstream. If you guys read the question to begin with, it starts with by saying that each person started with 200 milligrams. So they want 50% of that, meaning half of that. So this is the initial milligrams that they ingested. So you're going to divide that number by 2, which is also like saying 50%. So that means we're going to have 100 milligrams. That's what our question is. What time will they have? How many hours has it been since they had 100 milligrams? And they want it rounded to the nearest tenth of an hour. Okay, so in your calculator, this is our X value. So whenever they give you an X value, you're going to have to go to your calculator and press trace, enter 100, and then enter. So I'm going to have to do it using this button, number 1. But I'm going to press 100 and enter, and you should get that it's 5.9 hours. So we have our value, Y is equal to 5.9 hours. And that's our answer. Now, Paula drank, for question C, Paula drank a cup of coffee that contained 200 milligrams of coffee at 10 a.m. How much caffeine will be in her bloodstream at 9 p.m.? So what we need to figure out is how many hours have passed. So how many hours has happened from 10 a.m. till 9 p.m.? So what I like to do is I like to change it to the 24-hour clock. Makes it easier to subtract time. So on the 24-hour clock, 10 a.m. stays as it is. It's just going to be 10 on the hour clock, 24-hour clock. But 9 p.m. will actually be, so 9 p.m. will be then 13, 14, 15, 16, 17, 18, 19, 20, 21. So that will be 21 o'clock. Okay, so by changing it to the 24-hour clock, it looks like 21. That makes it easier to subtract them because you're going to take 9 p.m. and subtract 10 a.m. and that gives us 11 hours has passed. So once we know 11 hours has passed, you're going to have the y1 being your logarithmic equation, log equation, and your y2 is going to be 11. Okay, so we're going to go to our calculator and check that that looks like that. So go to y equals. We already have the logarithmic ln equation as y1, but we're going to put 11 as our y2. Then we're going to graph it, and you should see an intersection. From there, we press second trace, number 5. Move your cursor as close as possible to the intersection, and then press enter 3 times. You should find that there is 54 milligrams. So in our answer, we're going to find that there's 54 milligrams of caffeine in the body after 11 hours. So that's our answer here, because it says round to the nearest milligrams. And then our last question here, Paula is only able to sleep if her caffeine levels are below 40 milligrams. If Paula usually goes to bed at 10 p.m., what is the latest time that she can enjoy a cup of coffee? State your answer to the nearest quarter hour. Okay, so first we need to figure out how many hours will it take for her to process 40 milligrams. So they're giving us 40 milligrams, which is an x coordinate. So we're going to go to our graphing calculator. We're going to go to y equals first and remove that 11 because that's from the previous question. We're going to graph it. And what you're going to do is you're going to press trace 40 enter. So trace 40 enter. And what that will give you is, we know that it's going to be 13.56 hours. So let's write that down. So I did trace x equals 40 and then enter, and I got that the y coordinate is 13.56 hours. So what I want to do is I want to convert this because it wants it to know the exact time. So we want to know the exact time that this person should be drinking, the latest that she should be enjoying her cup of coffee. So first we need to find how many minutes this is. So we already know it's 13 hours, but we know it's 0.56 hours. So we need to take 0.56, which is this, and we need to multiply by 60 to find out how many minutes have passed. So 0.56 times 60 gives us that there's 33.6 minutes. So it's going to be 13 hours and 33.6 minutes. But they want us to convert to the nearest quarter hour. So quarter hours is like 15, 30, 45. So we need to round to the nearest quarter, which would be, in this case, we want to round up. The reason being is if we round down, we're going to have still caffeine in our system that's more than 40 milligrams. So we need to make sure we are below 40 milligrams. So we actually need to round up to 45 minutes. So we're going to round up to the nearest quarter hour. So that's going to be 13 hours and 45 minutes. Now our job is to figure out what time before 10 p.m. will it be? So if we're 13 hours and 45 minutes before 10 p.m., what time is it really? So we're going to convert 10 p.m. to the 24-hour clock. So that becomes 22 o'clock. So what we're going to do now is we're going to subtract 13 hours. So let's subtract the 13 hours right now. So if we subtract 13 hours, so 22 minus 13 gives us that so far we're at 9 a.m. But we still need to find out what is 45 minutes before 9 a.m. Well, 45 minutes before 9 a.m. will be 8:15 a.m. Okay, so what I'm doing is I'm saying that if I add 45 minutes to this, that's going to take me to 9 o'clock. And if I add 13 hours to this, that's going to take me to 10 p.m. So this is the latest that she should drink her cup of coffee if she wants to go to bed at 10 p.m. and not be alert and get some good sleep. So that is what you want to do in this lesson. So it's similar to our 6.5 lesson or 6.4 lesson. All you want to do though is use the right number. So in our case, in this lesson, we're using number for LN regression, logarithmic regression, number 9.